Welcome to Breadboarding. In the current series, we're making a breadboard PC based on the Intel 386 processor. And in the previous video, what we managed to do is to convert all the Compaq DeskPro program or logic definitions, which were in a PDF document, into a form that we can actually use to program the program or logic device chips. And during this video, I'm going to be showing you how I've taken the Compaq DeskPro design and then evolved it to work in the breadboard. So this is our breadboard adapter for our 386 processor. Some of the test boards, the clock and the test boards that I've got here, some of these will go. And what we're going to be looking at during this video is the schematic diagram to work out how to lay out all the components. So we're going to be having a variety of latches and buffers at the top here. And a lot of the bus control logic is going to go down the bottom here. So this is video 10 in the 386 Breadboard PC series. In this video, we're looking at the 386 bus control logic and the latches and the buffers in the KiCad schematic. So this is the Compaq DeskPro KiCad diagram that I reproduced from the original PDF documentation. This is up on GitHub. One thing I should say here, the one or two comments, if you do the validation rules on this, it will say about not all components are annotated. I would suggest you don't run any automatic numbering because the numbers on all these chips actually tie back to the original Compaq DeskPro documentation. So during this video, we're going to be looking at the CPU area, the address latches and bus control logic, the data bus latches and control logic, and also some of the bus state machine, which controls most of the CPU control signals. So this is the Breadboard PC version of that. So what I try and do with the Breadboard PC is I use the physical layout of the chips and I try and lay things out approximately in the breadboard layout. So you can actually get pretty much a physical layout based on the schematic here. And you can see down here that it indicates where there are going to be busy parts of the board, where there are a lot of wires going around, and you can try and actually move the components into the optimal place where they make sense. Now, what I've done is I've added this onto the previous Breadboard PC. So this is the version 2 project, and there'll be links for the earlier projects in the description below. You can see this was using the Intel 8088 processor, and there's quite a few sections of this I'm just going to be reusing. So the CGA video controller and a lot of the I/O for the floppy disk, IDE disk, serial port, and the keyboard and mouse. A lot of that stuff is going to be reused, as is a lot of the real-time clock and the interrupt controllers, all this sort of stuff. So I've put it on the same diagram for now so that as I copy this stuff over here, I'll delete the bits that I don't use over here. And you can also see here, this is the 7-segment LED display and keypad that will also be using in the early stages of the project to actually test the hardware before we manage to get MS-DOS and Windows running on it. So I should also say, following on from the previous video, so these are all of the program or logic device definitions that I was processing, and you can see here we've got the page in the original DeskPro document. If we switch to that, you can see this is the format that these definitions are in. In the previous video, we converted these into the current WinCUPL software that we use for programming these. Now, I have gone through all of these and I've actually programmed the chip and run the tests on it and run the tests in the programmer that I showed during the previous video. So all of these tests have now actually passed, and there were a few fixes that I needed to make, where there have been a few mistakes and things. I will post all of these files up on the GitHub project sometime over the next couple of days. And as part of the analysis, what I've done is for each of the program or logic devices, I've defined all the inputs and outputs that these have. And you can see these are all the different signals that make up the control logic. So this is a really complicated area of the system. There's a very good chance I'll make some mistakes here, but at least by double and triple checking all this sort of stuff, hopefully it will minimize those mistakes. What I've found from the previous projects is the more time you spend planning and double checking this stuff, the less time you spend trying to troubleshoot and diagnose difficult to find faults. So the main difference from this diagram and the previous diagram is that what I've done here is created a breadboard adapter version of this. So this means that all the pins here are actually arranged very much. You just look over here, we can see with the data bus buffers here can see that the pins are arranged here so they can literally plug straight into the chips. And the reason why we've got gaps and things here is to allow for these extra pins here to be able to plug in the various control signals. So hopefully what this is going to mean is that for the buffers for the data bus down the side here and for the address latches, these are just going to plug almost straight in alongside with the processor here. Then there's another row of latches and things that we're going to have to wire up. I'm using the bus rails here for doing this, but in reality what we'll probably end up doing is having some DuPont cables jumping over here, going over to here. So it will tend to hide some of the chips, so it won't be quite so easy to see things top down, but it's certainly going to be a lot easier to wire things up that way. So you can see here that we've got 4 buffers, and we need 4 buffers because we've now got data lines going from 0 all the way up to 31. And these latches over here are used for the sending 8-bit, 16-bit data back to the CPU. So when devices are perhaps only providing 8 bits at a time, then the timing signals will control the latching the data into the lower byte, the next byte, byte 2, and then ultimately byte 3. So the reason why these latches are needed here is to handle converting the 8-bit, 16-bit data into 32 bits for the CPU here. Then over here we've got most of the address control lines. So again, you can see that the processor address lines are on the left-hand side here. We only have to go up to processor address 23. So that gives the Compaq DeskPro 386 up to 16 megabytes of RAM. And the top address line there, PA31, is just used to control access to the numeric code processor, which we're not going to be bothering with during this project. And also there's a register up in the upper 2 gigabyte memory area, which is used to control access to a shadow copy of the BIOS ROM in the top area of memory. Now, 1 or 2 areas where in the original design there may have been a 200 series chip. I've replaced the 200 series chip with a 500 series chip, and the main reason for that is that all the inputs are on one side and all the outputs on the other side. If we look at the equivalent area on the other diagram, you'll see here that these are the equivalent chips, the 74LS244s. You can see that the input pins and the output pins are interleaved, so pin 2 and 3 are sort of come out, side by side. So for plugging into breadboards, it's a lot more complicated. So in some cases, I have swapped out some earlier generation chips for newer chips, and I will be consolidating things wherever possible. But what I have done is, you'll see here the U40 and U41, which are the Compaq DeskPro original schematic chip IDs. These have actually been carried forward into this diagram, and I've also carried them forward into the Breadboard PC. So you can see that 40 and 41 carried forward onto here. So it means that hopefully we'll be able to trace back things back to the original documentation. So if I have problems, then we can actually go back and have a look at the original schematics. So where it gets complicated is down the bottom here. Now, at the middle section here, I've actually just got the power supervisor reset and CPU clock. So this is the same logic that we had on the test board. So basically the reset button, the clock, and the various bits of logic to divide the clock and to handle the reset signal are actually there. So those are just going to be moved down to this section here. But then by far the most complicated bit are all these PLDs here. So many of the PLDs, and there is a 74LS273 sort of latch here, which is actually the state machine that handles most of the states of the CPU, going from 32-bit accesses all the way down to 8-bit accesses. And then there are a couple of areas here where I've actually got AND gates, NAND gates. Now in the original DeskPro diagrams, these were broken out as individual gates. So if we actually have a look at perhaps where some of these occurred, so the B hold A and BALE, this chip here, these are in fact these gates. So in the original DeskPro diagrams, these gates were broken out. When it comes to actually using these in the breadboard layouts, then it's easier to actually wire these up as in the chip layouts, just because then it means that you're physically wiring things up closer to what they're actually going to be. And you can see that there's a number of these chips which have got unused gates at the moment. So later on in the series, as we need to add more logic, then hopefully these gates will get used. Obviously, when the DeskPro 386 was being designed, then with the PCB layout, there was a bit more flexibility in squeezing things in. And then over here, we've got some of the wait, state, control logic, bus ready, no wait states. These come from the ISA bus, and this is how devices can request to extend memory access cycles, or even to say, I'm a nice fast device, you don't need any wait states for me. So this logic here is going to take quite a bit of testing, and this diagram here just indicates the interdependencies between all these things. So you'll see that in some cases there won't be any outputs on these lines, so the outputs may come from a processor or from the ISA bus. With a lot of the chips though, one of them will be handling the outputs and all the others will be making use of the inputs. Now, one of the things I was thinking here is that these sort of 7 or so chips which are used for doing all of the bus control logic are candidates for replacing with a complex PLD. And I had done a similar thing with the Breadboard PC Series 2 in that I used one of these ATF 1508 100-pin complex PLDs and was able to actually replace an awful lot of the logic for the CGA card with one of these chips. And I suspect most of this logic down here probably could be replaced by one of those chips. But since we've got all of the PLD rules already converted, and they've also been able to test them, and all of the tests are passed on the physical chips, I figured that getting this working first is probably the better thing to do. But you can see that the dependencies between this and the opportunity for making mistakes is quite high. But the advantage of using KiCad like this is if we wanted to see a particular pin is connected to, obviously we can do it on this diagram here, for example. Then we can cross-check, for example, with this diagram here, and even if you wanted to, then you could go back to the original DeskPro schematic. You can see here the T01 here. So I've tried to lay things out on the KiCad DeskPro almost the same as the way how they're laid out here. So there almost certainly will be some mistakes along the way, but hopefully if we can go back to the original diagrams here and then check off against the other two KiCad diagrams, I'll hopefully be able to get to the end of this and eliminate any mistakes. So hopefully that's given you a feel for the progress we've been making. A lot of this stuff does take quite a long time to go through. What I have learned in previous projects, if you rush things, then you inevitably make a lot of mistakes and you spend way longer trying to sort them out. So in the next video, what we're going to be doing is actually wiring up all of the chips and putting the chip labels on all these, and that will hopefully be in the next week or so. So if you don't want to miss out on future videos, please hit subscribe, and if you found the content interesting, please hit like. It just helps to make the videos available to more people. If you'd like to leave comments below the video, I do try and get back to you within a day or so. Thanks for watching.